We're going to talk about transformations to the exponential function. This is always your base. This tells you whether it goes right or left. This tells you if it goes up or down. This is also your asymptote. That's important. Please write down that number tells you the asymptote. This number in the very front is your vertical stretch or compress. Remember, if it's less than 1, it's a compress. If it's greater than 1, it's a stretch. Your base, if it's greater than 1, it's growth. If it's less than 1, it's decay. So just a quick example. Let's say you have 7 times 2 to the x plus 3 minus 5. Okay, this is your base. Is this going to be growth or decay? Okay, so this is growth. Your base tells you if it's growth or decay. This tells you what? It's going to go down 5. That's where your asymptote is. So at negative 5, you're going to draw your asymptote. Since it's growth, I know it's going to look like this. However, it's reflected as well, so it'll look like that. Make sense? All right, great. Let's go ahead and look at some of your examples. Is this growth or decay? Good, that's less than 1. 3/4 is less than 1, so that's decay. Which number should I be looking at? The 4, not this one. What does this tell you? Yes, that just tells you that it's a vertical compress. 4 is your base, so this is a growth. Is this one growth or decay? Growth, because 5/2 is bigger than 1, so this is growth. Let's look at a transformation. We have a parent function. This is our parent function, 2 to the power of x. But it was reflected across the x-axis. What do I need to put on here? A negative in the front. Then it was shifted 2 units to the left. So what should I put up here with x? Plus 2, good. And then it was 6 units down, minus 6. So if I were to graph this, I know it's down here at negative 6, there's an asymptote. It went left 2, so I guess you really won't see the effect that well. It's going to look something like this. However, since there's a reflection, it'll look like that. Make sense? Great. Let's look at how we graph. So I'm going to give you guys a function. 3e to the x minus 1 plus 4. Okay, guys, this is my base. Do you guys remember what e is equal to? 1/8? Okay. So is that greater than 1? So this is growth. If it's growth, it's going to look like this, right? So we kind of know what it's going to look like. Let's answer these questions. First of all, where is my asymptote? I know that for sure. 4. Everyone put y equals 4 for the asymptote. And then go ahead and draw your asymptote at 4. So at positive 4, I'm going to put a dashed line. That is where my asymptote is, right here. It crosses the y-axis at 4. If you just put on the test 4, I'm marking it wrong. 4 is just a number. I want an equation. This is a line, so we need an equation. Okay, so we know our asymptote just based off of the equation. I know it's growth, so it's going to look something like this. So guys, what's my domain? Yep, it will always be all real numbers. All right, Dwight, what did you put for the range? Perfect. Why didn't you say greater than or equal to? Exactly, it never touches 4 because that's an asymptote. Jimena, what's another way we can write this? Where's the bottom? So I'll just put 4 and put a parenthesis so we don't equal it. Okay, and then where's the very top? Yep, that's another way you can write it. 4 to infinity. Notice, guys, I did not put a bracket. If I put a bracket, that means we can actually equal 4. So it'll be a parenthesis. That's another way you can write your range. Okay, Madison, as x goes to infinity, what's happening to the graph? Yep, it goes up. So I'm going to put infinity. All right, Henry, as x goes to the left, what's happening to the graph? What's it going towards? Yep, it goes towards 4, the asymptote. Very good. All right, Lydia, how do I find the y-intercept? Exactly. I plug in 0. I'm going to write that down. Plug in 0, 0 for x to find the y-intercept. So guys, what I'm going to do is I'm going to put a 0 right here for the x. Put a 0. Okay, so I'm going to help you guys calculate this. 0 minus 1 is negative 1. Whenever you have a negative exponent, you can write it like this. Put it in the denominator. Did you guys know that? You guys should remember that whenever you have a negative exponent, you can put it in the denominator. Remember, this is a rule. So I just put it in the bottom. I flipped it. If you're confused as to why the 3 is on top, I'll separate your steps. There's still a 3 in the front, and we wrote it like this, right? You can imagine a 1 there. 3 times 1 is 3. 1 times E is just E. Okay? Now type this into your calculator. If you don't have an E button, what can you put instead of the letter E? Yep. 2.718. Type this into your calculator. Let me know what you get. Great. So y'all got 5.1. That's about, let me rewrite my graph. 5.1, that's about right here, a little bit above the 5. So draw your graph. There you go. And notice, guys, I was able to answer most of these questions without even having to draw a graph, just based off of the equation itself. All right. So guys, we know that the domain is always the same, negative infinity to infinity. This right here tells you the asymptote. It's at -7. The range, I know it's going to be everything is greater than -7. I know this is growth, so it should look something like this. Since it's down here at -7, your asymptote's at -7. It'll look like this. That means I know my end behavior, infinity and then down to the asymptote. Your y-intercept, you just have to plug in a 0. Okay, so if I plug in a 0 right here for the y-intercept, what's 2 to the power of 0? 1. So I'm going to get 1/4 times 1 and then subtract 7. What is this? Just 1/4? What's 1/4 minus 7? What'd y'all get? -6.75. So 0, -6.75. So if I were to graph it, I'll go down here and put my asymptote. 1, 2, 3, 4, 5, 6, 7. There you go. And my asymptote, or my y-intercept, is between -6 and -7. And there you go. Guys, a quick way to graph these, if it's growth, it looks like this. Write that down. If it's decay, it looks like this. Yes, so if you have a negative in the very front, so let's say I have a negative in the front. Just flip it across the what axis? What axis do we flip across? X-axis. If there's a negative in the front, you flip across. You flip across the x-axis. So this one would look like that, right? You flip it across the x-axis. So this one would look like that, right? That's what those four graphs look like. So you flip it across, boom. Flip it across, boom. Okay, so that's what those look like. This is if you have a negative in the front, a negative in the front. Thumbs up if that makes sense. Okay, good. That's it.